Why? Why does your code do this, right? How many of you have this feeling, right? This is everyday life, right? And I bet I know what your immediate reaction is. As soon as you see that code, you're like, I'm going to rewrite everything, right? I can do this. I'm really good. I'll just rewrite everything, right? That's the instinct of coders. We are better than everyone else, so we can rewrite this into perfect code. Turns out that rewriting everything is not really possible, right? There's this little thing called clients. How many of you have clients? Right? They tend to only pay if you deliver. So if you just try to rewrite everything, you will never actually deliver the product. So you're not going to get paid. So what we usually say whenever you start talking about testing and quality and doing more and delaying these things, people will tell you that real developers ship stuff. Right? How many of you have heard this as an excuse for really bad code? There you go. We hear this all the time. So shipping stuff is great. I mean, we do have to deliver, and that's really good for us. But is shipping stuff enough? Right? So let's talk a little bit about a project. This is the Tacoma Narrows River in the United States, near Seattle. And, well, they had a river, and people needed to cross the river. So they built a bridge. Right? That sounds like a good solution. They needed a bridge, so they went up, found a diagram of a bridge. This is what a bridge looks like. Let's build a bridge. Like installing a new WordPress template. You find a template, you put it in, and you have a bridge. Great. That sounds like shipping, right? Delivery. That's what people keep telling us to do. This is what we need to do. We need to deliver. So a couple of months after that, literally 4 months after the bridge was built, the wind picked up. Any engineers in the room? Does this look like what a bridge should be doing? Just not really, right? So the wind picked up just a little bit more, right? An unexpected situation. Imagine that you're getting more traffic on your website, and all of a sudden your website starts doing this. That's probably not good, right? This is what happens if you just ship, right? Picture this is your server right now, going down in flames. Right? Nagios is sending SMS to everyone, and you're getting up in the middle of the night to go fix something. So just shipping it is not enough, right? We need to also bring quality, because as it turns out, well, thankfully, no one was killed while this bridge went down. However, there was one fatal fatality. A dog. A dog died. So if you write bad code, you kill puppies. Think about that. Right? So obviously, just shipping, not enough. How do we find a balance between writing code that's good, writing code that's going to allow us to do maintenance, and still deliver on time with the deadlines we have, with the clients we have? Right? This is what I want to talk to you about today. So first of all, we need to understand what happens to code in general. Why is it that we look at code we wrote a year ago, 6 months ago, Friday, right? Why do we look at this code and feel that we need to fix it, we don't like it? Thing is, code has an expiration date, right? It's written, it's like perishable goods, right? If you keep a yogurt out of your fridge for long enough, it'll turn green, and that's probably not good. And code is the same thing. Code has an expiration set on it. And the reason for that is simple. Code evolves, right? The stuff we work with, it keeps getting better and better every year and every month. That's because languages also evolve, right? We mentioned PHP 7. How many of you were in PHP 7? All right. That's what you want, right? I mean, everyone who's not on PHP 7 is probably like wishing they were already on PHP 7. We want the new shiny features. We want to get there. We want to use all of these things. And that's fairly natural because code keeps getting better. The other thing that also evolves a long time is you. You as a developer learn new ways to solve problems. We learn better ways to solve problems, right? And that's really good, because as it turns out, if you do not dislike the code you wrote in the past, it means that you didn't grow. You didn't learn anything new. So the actual trick here is you want to hate the code you wrote because it means you learned something. It means you have evolved, right? So keep that in mind. So looking at other reasons why code causes these issues, you can look, for example, at comprehension, right? The art of understanding other people's code. And the more complex that code is, the harder it is for other people to understand it. If you take someone else's code and you pick it up and you read it, if it's complex, if it's convoluted, you will not understand what's happening. And that makes it really hard for you to go give maintenance, which means we want to rewrite everything. The other reason is just bad design, right? If you do something wrong from the beginning, it's just going to go wrong for the rest of it. Right? So it's very important for us to understand what bad design is and what good design especially is. And then finally, as we mentioned, we have clients. And clients bring with them bad specs, right? How many times have you sat down with a client to figure out what a project is? You came up with a project idea. 2 months later, the project changed completely. Does that sound like a client interaction? Right? Clients were put on earth to change their minds every day. Right? That's it. That's the nature of what we're doing. This is why we have Agile. We want to be able to react to change, because these specs, they keep changing all the time. And then the other thing that really makes us hate old code is NIH. Anyone know what NIH is? Try it out. Not invented here, right? So the German art of saying that anything that's not German sucks. That's essentially where it came from. I don't know why, but it sounds familiar. But the idea is, why use someone else's code if I can do it better? I have my own thing that does whatever is needed here. I don't need to use someone else's code. Or I can do it better than everyone else, right? It's our developer ego showing. And that really makes us reinvent the wheel plenty of times. So today, you'll be happy to know that I have come with the solution. I have the silver bullet that will solve all of your problems. And I'm lying to you. That's not true. There is no one solution. We all know this, right? If there was one solution, someone would have found it, would have sold it to everyone else, and would be rich. And that has not happened yet. Right? So there is no one solution because it's not really a problem. Code will expire. Code will go bad. The real problem that we're facing is how can we write code that allows us to react to change more easily? Because change will come. How you go into the code, change it to now face this new challenge, that's where it matters. I mean, if it's easy for you to go and switch a module or change a feature, you will just do that, and that's fine, right? When we really complain about other people's code is the moment where you're trying to add a button here, and everything over there breaks, right? The code is resisting you, so that's what you don't want. So I want to give you a couple of ideas of things to keep in mind as you're designing code. And then I want to dive into one solution that I found, which is a set of exercises, which are really interesting. So in order to make code better, in order to improve code, we need to do a couple of things. First of all, we need to make it easier to understand. Right? If you write code that's simple, that's clear, people understand what it does, and they can change it easily. The other thing you can do is make code flexible, right? If you need to make a change to code and it's easy to do so, you will just make that change and move on to the next client, to the next work you have to do. You also need to make it tested. Making code testable, I mean, every code is testable, it just depends how much time you try, right? You don't want that. You want code that's easy to test, code that's easy to get through with. You You also want code to be easy to replace and refactor, right? Refactoring is part of what we do as developers on a constant basis. And finally, so if I must offer you one solution that will solve all of your problems, and this is guaranteed, you just make code not exist. If you don't write code, you won't have problems. See? Great solution. So, I don't know, my big plan is to go sell coconuts on the beach. Maybe you want to try that? Okay, well, but that's exactly it, right? There are plenty of ways for us to get away of actually writing code. We can use other people's libraries and the other things. If you do not have your own code to maintain, that does make life easier. So let me cover some of these just to give you an idea. For example, testing, right? Testing is a very important part of what we do. And people usually look at testing with the wrong mentality. Does anyone know what testing is really for? Any guesses? No? Do you think testing is about quality? Do you think testing is about confidence? There we go. Testing is not about making sure your code does what it should do. Testing is about giving you the confidence that you can go into a piece of code, make changes to it, and it will still work. That's what it's all about. It's all about confidence. It's all about giving you the confidence to make changes, to refactor, to make that code better without causing damage to your business. Right? So testing is all about confidence. Because we as developers should, every day, be doing refactorings. Right? So refactoring the code is part of what we do. The idea behind this is that you always take code and leave it better than it was when you touched it, right? So every time you work on this part of the code, you see, okay, can I make this better? Can I simplify it? Can I separate it even more? And for that, it's really important to have tests, because refactoring without tests is essentially just moving things around. It's like playing Jenga, right? Let me see if I can change this, and the whole thing comes crashing down. That's not good, right? You want to have confidence. So when you pull that little, piece of wood out of there, nothing else breaks. That's what we want from testing. The other thing is understanding design concepts, right? This is something that we need to understand from the get-go as we start being developers, because these will give us a lot of things to work with and think about as we progress in our careers. I mean, one of the easiest places to start is the concepts of solid and stupid. Everyone familiar with these two? Okay. So essentially, it's easy, right? It's the stuff you should do and the stuff you should not do. Right? There's not much complexity there. But things like single responsibility, guaranteeing that a piece of code does only one thing, and that's it. Right? It makes that code simpler. It makes that code easier to follow. Using dependency injection, dependency inversion, all these tactics help us make the code simpler, easier to read, decoupled, separate, so more flexible. Right? As opposed to doing things we shouldn't do, just doing stuff prematurely, writing singletons, duplicating code everywhere. These are things you want to avoid. Now, there's plenty of material on Solid out there. I do recommend you go take a look and learn a bit more about these concepts. And along the way, the other thing you should learn about is design patterns. Right? Design patterns are essentially templates so that we can communicate the same way. Right? The idea behind a design pattern is that if everyone's using design patterns, you can understand better the mentality behind of how you solve that problem. Right? So design patterns are a really good thing to know. You can read the Gang of Four book. It's boring, very boring, but it does give you nice ideas, right? And I don't mean you should know the name of every design pattern, but you should be able to identify the purpose. Like, I don't know the difference between a strategy pattern or something else, but when I look at the strategy pattern being implemented, I understand that purpose, right? It's like having this common language that all developers can talk about. So design patterns really help you with that. The other thing is domain-driven design. You heard a talk from Rob this morning talking about domain-driven. And this really helps in the communication between the development team and your business team. All of these concepts really translate to code that explains itself. And that's something that you really want. And then finally, things that allow you to do more modular architecting, right? Things like event sourcing, CQRS, techniques that essentially allow you to separate code from the different parts of the code, right? The different bounded contexts. So, if your pieces are more separate from each other, it's very easy for you to replace one piece with something else. Obviously, then we also talk about package managers, Composer, meaning you can avoid NIH and start exercising Pi, right? Proudly invented elsewhere. This is where we start using someone else's code, start relying, for example, as Rob said, if it's something in your infrastructure layer, you don't need to reinvent it. If you're sending emails, use Swift Mailer. If you need a dependency injection container, maybe use Symfony's dependency injection container. Just don't reinvent those wheels. Cool. So this is all just general ideas, just concepts, just so we start understanding where the problem is and what we're tackling. So a few years ago, I was working with a really good team of developers, including one of the core developers from Doctrine. And we had a really good job. We actually had no clients. Best work ever. But we had a lot of time to think and look at what we were doing. And we were looking for a way to help us, start writing better code, become more aware of the design decisions that we were making. So we ran into a concept called object calisthenics. Anyone familiar with it? Okay, a couple of you, great. So object calisthenics was a pretty interesting concept. It was written by a guy called Jeff Bay in the ThoughtWorks ontology book. And the idea behind this is calisthenics means small exercises, repetitious, that you repeat over and over, that lead you towards a bigger goal, right? When you apply that to coding, it's essentially a list of exercises of ways to write code that if you try these on for a while, you start realizing that your overall vision of code design becomes a lot better. And that's a very important part of this, right? These are exercises. They're not rules, they're not coding standards, they're exercises. So essentially you take this, you try it out for a month or two, follow all of these guidelines strictly, and you'll realize that as you do that, you start becoming more aware of other design issues around your code, right? Like how information flows, how objects communicate to each other, how your methods look, how simple they are. So essentially, the original rules were 9. They were written for Java. We ported them into PHP, to adjust a bit to our reality. When we ported them, this was, 6 years ago, we made them very loose and easy. Since then, I have tweaked them up back to the original strictness. And it's an interesting exercise. So I want to go over all of these with you. So, guideline number 1 is only use one level of indentation per method. Is that concept clear? So when you break into a function, you don't go past one level of indentation, right? So if you try to put an if within a for each, that's 2 levels, that's too much. You don't go further than that one level of indentation. Does that sound crazy to anyone? Bit crazy in the back? The interesting thing is, as you start doing this, again, this is an exercise, you start forcing yourself to reduce what the method is doing. Because you start, losing space to do more things. And this really helps with the single responsibility principle. One method should do one thing, and one thing very well. Not 2, not 3, just 1. So sticking to this, really helps you. It's really hard to do more than one thing if you can't do more than one level of indentation. So that's the idea behind that exercise. Now, exercise number 2 is an interesting one. And it's usually where people start calling me crazy. So let me know if you find this crazy. But the idea behind number 2 is you do not use the else keyword. Okay, no one threw anything. That's good. It's a good start. How many of you disagree with this? It's okay. No one. Everyone agrees. Oh, great. I'm done. I'll hand this over back to the conference. No, so this kind of feels odd, right? What has else ever done to you? Like, else is a nice keyword. Come on. So the idea is this. Consider this code here. And it's essentially a simple Symfony controller action, right? It's creating a post. So it will receive the data, create a new entity, validate the form data from that entity, and then try to create it in a database. If it's duplicated, it stops. Right? So pretend you're doing a code review for me and you're looking over this code. Took you 1-2 minutes to go over it, make sure everything is okay. So now let's say, okay, we don't want to use these else's. Let's analyze this code a little bit better. If we look at this entire method, we see that this part here is actually what the method is supposed to do. Create a blog post, save it to the database. That's it. This is what this method was intended to do. Everything else around it is just error checking. Right? So we have all of these ifs and else's here just to do error checking. If this is good, do that. If this is bad, do the other one. Right? And we create all these mental forks. Obviously, we know this raises complexity of the code. As you have each of these forks, the code gets more and more complex. As you are reading it, you're now having to keep all these things in your head. Which path did you go, and etc. That's not good. So how can we rewrite this without the else's? And let's see how that works. So if I just rewrite that, and I extract both the if here and the other there, what I do is I switch the logic. Instead of checking for what I want, I check for what I don't want. Right? I check for the opposite. Now, I have an exit condition. What does that mean? That means that this is a condition with which my code cannot proceed. Right? Again, we said methods should have a single purpose. The purpose of this method is to create a blog post. So it will try to create a blog post, unless some conditions don't meet. For example, this one. If the form is not valid, stop. Stop, carry on, throw it somewhere else. Something else needs to handle that situation. Same thing goes for the second one, which is where we check if it's not duplicated in a database. So if you look at this code now, it's a lot easier to understand what the code is doing and what the conditions are where it should stop doing what it's doing. Right? And now you have exactly what the method is supposed to be doing right there. So everything else, essentially, you can now ignore. You've removed the else's, so the complexity of the code is a little bit lower, but it's easier to read. It's easier to navigate as you're reading this. And then you can go a step further, because what you realize now is that those two conditions are not the responsibility of your method. Your method should understand that by the time things get to the method, everything is okay. The method just does what it wants. And you can rewrite it as this. Right? So I have just deleted the code. That's great. Deleting code, no problems, right? The rule needs to be somewhere. I mean, if you're familiar with PSR7, with middlewares, we can just extract these things into a form validation middleware and a unique entity validator, for example. Right? These middlewares happen before the controller, so by the time the action gets to the controller, all of these situations have been checked. Your controller is now focusing only on doing what it needs to do. And then your form validation is focusing on what it needs to do. Right? So it just makes everything that much more simpler and direct because everything is doing one job. Does that make sense now? How many of you are sleeping after lunch? There's a lot of food, I understand. Cool, so PSR 7 really helps with that. And essentially what we're doing with the second rule is avoiding situations where we have a complex tree of decisions and turning them into a simple direction that the method should follow and points where things should stop. Now you can do either an early return, which some people don't like, or you can throw exceptions, right? I mean, this morning we were here asking for more exceptions in PHP, and this is where you can really use them. Just throw exceptions. So this method is not supposed to do this. Throw an exception, something else will handle that exception at the right moment and do the right thing. Let something else communicate to my client because my method doesn't need to do it. Cool. Number 3, wrap all primitives if they contain behavior. Or just wrap all primitives, period, because Nikita has just taught us that arrays are more expensive than objects, so let's put objects everywhere. Objects are good, right? What does this mean? If you look at a method like this, it says component, repaint, false. Wait, does that mean I should not repaint? It's very confusing as you read this, right? Now, if I replace this with something like this, where I create an object to wrap that false, to wrap that Boolean, it becomes a lot easier as you're reading this, right? You don't have to go back to the method registration to understand what happened there. And there's an extra gain here. All of the functionality that relates to animation can now be moved into this object, which means the repaint method is now, again, only doing one thing. Different example of this is, has anyone ever used the money PHP library? Okay, has anyone ever tried doing money handling in PHP? Did anyone have fun doing that? If I mention money and floating points, does anyone get fidgety? Yeah, okay, that's not a good idea, right? So things like money PHP is essentially the same thing. Instead of just using a number, a primitive, an integer, or a floating point, please don't do that, we now use an object. With that object, we can then do manipulation on top of it. We can do proper rule checking on it. And it also means that complexity of, should it be an integer, should it be a float, whatever it is now handled within that object. You now have one place for all your money problems. That sounds weird, but again, one place where all of that happens. Right? So wrapping primitives not only helps you communicate more information to whoever's using your code, it also allows you to put all the behavior in there. Cool. Number 4, only use one error per line. Now, I'm not against fluent interfaces. That's not what this is. You can use fluent interfaces as you like. But I'm talking about grabbing something from an object and doing something with it, and then doing something, and chaining, right? When you chain all of those calls, has anyone familiar with the law of the meter? Right? It says you shouldn't know things about all those layers behind the other object. Take, for example, this example from Symfony. If you ever talk to the token storage, you know exactly what's going to happen here, right? So there is a scenario in Dear Symfony where get token returns null. And what happens when you do that? Fatal error. Unless you're in PHP 7, then you get a beautiful exception. Right? So you're assuming too many things about the objects you're calling. You're assuming that get storage is always going to return an object that is a user. But if you don't configure the proper firewall, that doesn't happen. Right? So this is what you want to avoid. You don't want to, you only want to talk to your direct friends, not to the friends of your friends. It's kind of like Facebook. You only want to talk to the right people, not all that other stuff around it. Right? And then that leads me to exercise number 5. Do not abbreviate. Now, abbreviating is interesting, right? When you take a really long word and you abbreviate it into this 3-character variable, it feels good, right? It's like, I've made this great thing. It's now so simple. It's like this little word. It's amazing. And then you go read it tomorrow, and you're like, I don't know what it means. Right? It happens all the time. I mean, look at this code. I'm sure someone felt very smart when they wrote it. But there's no more meaning here. It's very hard to understand. It's actually so hard to understand that a friend of mine gave me this sample for the talk, and actually he can't explain it. Right? Because he doesn't remember what half those things mean. I mean, is that New York? I don't know. What's it doing in there? Right? So abbreviating feels like a good idea when you're doing it, but it doesn't pay off in the end, right? You want to be sure that you're passing as much information, right? This is where domain-driven concepts really help, where you have a ubiquitous language and you use that language throughout your code. You communicate more information, right? It's also a bit of subtleties on how you name methods, and this is going to be a little bit harder since not all of you are native English speakers. But if we have a method called getPage, we assume it's a simple getter, right? That it has no memory impact or performance impact. But what if I tell you that the getPage method does a curl call to a website and then downloads it? You're probably not going to want to call it 5 times because you get all that HTTP overhead. Now, if you rename that method to download page, for example, then people will start thinking twice before calling it. Number 6 is easy. Keep your classes small. And when I mean small, I mean your method should have 10 to 15 lines, tops. And your class should have 10 methods, if all that. Right? Keep them really small. Keep them short. That's really going to help you with making sure things are only doing that one thing very well. Number 7, limit your instance variables. Now, if you don't know what an instance variable is, if you use Symfony or dependency injection containers, these are your instance variables, right? These are properties of your method that receive other objects you interact with. Now, if you have all of these in an object and you depend on all of these things, 1, this object is doing too much, right? 2, does anyone think testing this is going to be fun? No, right? You're going to have to mock all these things, and that just takes too long. And you're not going to want to do testing because I'm not going to mock 7 classes. Oh, this is horrible, right? However, you can start taking these things out and simplify so that you only have 2 dependencies. Maybe things like the image cropper can go into an event that can listen. I mean, your user does not need to wait for their avatar to be cropped. Things like the entity manager, you don't need it. Make the user service call flush itself. So there's all these things you can do to make sure that all of the objects, they talk to a limited number of dependencies, right? So you don't have this complex tree of everything depending on one class. Number 8 is a little bit easier. It's just using collections. This means that any object that is a collection only has collection stuff in it. So add, remove, filter, map, reduce, these things, right? It makes it really easy for you to take these collections, share them, combine. It just makes the code flow a lot better because you're not mixing collections with actual entities in your project. The entities are what's in the collections. Number 9, don't use getters and setters. Now, setters is really easy, right? We want immutability. We want the object we create at the beginning to get all the way to the end being the same. That's fine. That's easy to agree with. Now, getters is like, why? Why do you hate getters? What's the problem with getters, right? And that's exactly what Rob talked about in his talk, about behavior, about transmitting information with that object. So, for example, if you have a method like this, right, where we say set score, get score plus 1, the behavior of scoring a point is now outside of our object. We're getting raw data from it to manipulate it and do something with it. Whereas instead of doing all this, we can simply move all that knowledge into the object. So if you're tempted to write a getter, really consider what is happening to your data. Or maybe just have methods that are not even getters, they're just reading the properties. In some cases, If you had Java, for example, you could use assessors, so you could just make things public. It's fine. PHP doesn't have that, so it's a bit of a juggle in there. But you can get away with things like this, right? I'm not talking about value objects precisely, like some entities do need getters, but your services, all these other things, they shouldn't have getters. Like you should never ask your user service to get the entity manager. That's something that's inside of your service, not outside of it. It's a bit complicated, but if you start sticking to this, you start realizing that the communication that you do with your object becomes a lot clearer. And then finally, step number 10, which is really easy, it's to document your code. Now, I don't mean putting before an if, well, in this block, we're going to choose between A and B. Yeah, that's what if actually means, so you don't need to do that. But what you want to document is you want to make sure that all the information required for the next person looking at that code to know is there, right? So you're telling him, look, this idea I put behind this object or this method is really complex because we had to choose between this and that and things like this. You really want to communicate, right? Think about this as, the person who's looking at that code next to you, what do they need to be able to work on that code and not want to rewrite everything you did, right? Think about moving it forward. So those are the 10 concepts. It really depends on you to try these things. I really think all of you need to focus on improving yourself. As one of my friends says, no boss is worried about your career. That's what you should be worried about, right? And you should always try to improve yourself and keep your career moving forward. And this is what we do at conferences, right? We come here to learn from other people. We come here to learn from the people who came before us and have something good to share with us, which means you need to read lots of code. Just read lots of code. The only way you can know what's good and bad is if you've seen all of it, right? So the more code you get exposed to, the better you can see which code is good or bad. Writing simpler code, right? This is something we should strive for, making sure that our code is easy to understand. It does that one thing very clearly. And then just try this for a month, right? Try this on your pet project. Don't worry if you can't do it at work. If you contribute to open source, just try doing it for a month. Stick to it and see how that resolves to you. What I found is that it made me a lot more aware of the design around my objects, how they communicate. It made me more aware of overall quality, right? I've also not written an else in over 5 years. Or maybe? Yeah, around that. Maybe 1 or 2 else's here and there. But I really, just stopped using this because you start thinking in a different way. With that also, composers out there, there's libraries everywhere. Use other people's code, share it. Just stop rewriting the wheel, reinventing the wheel. Rewriting the wheel is horrible. But just stop doing that. And, just be a craftsman, right? This is our craft. This is what we do. Look at your code and shape it the way you think it should look like. Thank you very much.